Okay, so continuing on with these examples, we're doing the same thing. These ones are already put into log expressions. Okay, so we can calculate it, but I want us to also write it as an exponential. If it's a log, I want you to be able to express it in both ways. So this would be expressed like this: 10 to the power x equals 4. Okay, again, these are not related bases, so it's going to be hard to guess this, but we know that if it's 10 to the power 1, it's got to be, it's too big. So we need an exponent less than 1. So to calculate this, I'm going to use the log form of this to calculate. So I go log base 10 of 4, I get 0.60. So here from the log form, I get x is approximately equal to 0.60. I'm going to use 3 decimals here, 0.2. And that means that the exponent less than 1, which is 0.602, that exponent will give me the number 4. And in fact, when we think about less than 1, we're talking about probably roots here. And if we do some sort of root of 10, we're going to get 4. Here we get 10 to the power x equals 83. I know that's got to be between 1 and 2. I can't solve it in the exponential, so I'm going to rewrite it in the log expression. And then now I can use my calculator to work out this number. And I kind of have an idea what this number is. It's going to be somewhere between 1 and 2, because 10 to the power 1 is 10, 10 to the power 2 is 100, so 83 is somewhere in between. So I get x is equal to 1.919. Okay, and we can get a fair degree of accuracy because our calculator has a calculation method that allows us to guess and test essentially much quicker than what we could. So here, this one, we're going to rewrite as an exponent. 10 to the power x equals 10,000. Now this one we shouldn't use a calculator because base 10 and 10,000 are related bases. They're related through base 10. And we should be able to figure out, well, what exponent gives us 10,000? Well, if we use our calculator, we'll get x equals 4, but we really shouldn't use our calculator for ones like these because these are related bases, and we are expected to solve for related base problems without a calculator. So that answer is x equals 4. Here, do we need a calculator, or can we do this in our heads? Well, base 10, 18,000 are not related base numbers. So we need to convert this into a log, and we need our calculator for this. Okay, so log equals exponent x. My calculator is going to give me a number bigger than 4, but it's not going to be less, it's got to be less than 5 because 10 to the power 5 will give us 100,000. So log of 18,000 is going to give us 4.255. Okay, so x from our calculator is approximately 4.255. Okay, and again, we can test all these back by using exponent of base 10. Okay, and we should get the same number back if we plug the exponent of 4.255 into the base 10 to the power x. So again, the idea is, we do need to be able to do some calculations, but the bigger idea is we want to be able to convert from logs to exponents. So this is not a log, this is a log problem, exponential problem, but I want you to solve for a. So 10 to some power, this number is the answer to 10 to the power 5. So it's much easier to rewrite this as exponent to see what the solution is. Log base 10 of a equals 5 means 10 to the power 5 equals a. So a is equal to 10,000. So this problem, although it's written in logs, it's easier to solve an exponent. This one is written as exponent, but it's easier to solve as a log. Okay, here, this is written as a log, and I can rewrite it as an exponent. Okay, but really, we can use